If you're building modern web apps, you already know the drill, right? Optimizing front-end performance feels like an endless battle. We're constantly hunting for that architectural edge to make things faster, smoother, and lighter. Well, today we're diving into an explainer on the Svelte revolution, mastering compile-time front-end performance. We're going to look at a framework that's literally turning the traditional approach upside down.
Okay, let's dive into this. Ask yourself right now, is your web app carrying unnecessary weight? Are you feeling the absolute pain of heavy, slow applications that seem to take forever to load and even longer to actually become interactive? Look, we've all been there. You're just staring at a blank screen or a loading spinner simply because the browser is struggling to parse massive JavaScript bundles. It's incredibly frustrating.
So, here's our roadmap for today. First, we'll look at the front-end performance problem. Second, Svelte's compile time magic. Third, the lightweight advantage. Fourth, we'll check out some real-world case studies. And finally, number 5, we'll weigh the challenges and considerations.
All right, let's jump right into section 1, the front-end performance problem, and specifically the heavy burden of runtime processing. To really appreciate Svelte's solution, we first need to understand the universal pain point developers are facing. Traditional JavaScript frameworks, industry standards like React, Angular, and Vue, do their heavy lifting right in the browser at runtime. Interpreting code in the browser inherently increases bundle sizes and processing overhead. Think of it like this. Instead of serving your user a finished product, you're essentially shipping them a flat-pack box of IKEA furniture and forcing their device to read the manual, sort the screws, and build the whole thing right in their living room. It takes up space, it's incredibly slow, and honestly, it just provides a terrible user experience. That, in a nutshell, is the problem with runtime processing.
Which brings us to section 2, Svelte's compile time magic, and how it's shifting that workload entirely.
When you contrast the two paradigms directly, the difference is night and day. You've got the tangled, heavy mechanics of traditional runtime frameworks on one hand, and then Svelte's streamlined compile time approach on the other. Svelte acts as a massive disruptor here because it moves all that heavy computational processing out of the browser completely. Instead of making your user's device do the hard work of figuring out how the application should run, Svelte handles all that mechanical heavy lifting on your servers, right during the build process.
So let's define exactly what this mechanic is. Compile time optimization is the process of transforming application code into highly efficient, imperative JavaScript during the build process, way before it ever reaches the browser. Remember our IKEA analogy? Well, this is like having that furniture delivered fully assembled straight from the factory. By the time the code hits the user's device, the browser doesn't have to think. It doesn't have to interpret a heavy framework or parse complex reactive logic. It just seamlessly displays the finished, highly optimized product.
And this brilliantly illustrates why this architectural shift yields such massive direct benefits. We're talking significantly reduced bundle sizes, which instantly and positively impacts load times. It gives us vastly improved execution speed because, well, runtime processing is essentially eliminated. Plus, you get minimal boilerplate, which simplifies the entire development process and cuts down on potential bugs. And finally, it ensures highly efficient reactive updates, meaning the browser only re-renders the exact parts of the DOM that actually change. No wasted effort.
Moving on to section 3, the lightweight advantage. This is all about Svelte's holistic approach to architecture.
Svelte's entire philosophy forces applications to be inherently lightweight by design, and that starts with a massive omission. There is no virtual DOM. Most modern frameworks use a virtual DOM as a middleman to figure out what needs to change on the screen before they actually go ahead and update it. Svelte just ditches it entirely. It's kind of like a magic trick. By removing that middleman, Svelte's components are inherently lighter. It slashes computational overhead, minimizes the JavaScript executed in the client, and dramatically lowers the CPU usage on the user's device.
On top of that, Svelte handles state management natively. The crucial point here is that it's simple, it's powerful, and it totally avoids complex external dependencies. As a developer, you don't have to carry the extra weight of third-party state libraries like Redux or Vuex just to get your app to remember things. Everything you need to manage the state of your app is already built in, and it's optimized for performance right out of the box.
Let's look at section 4, real-world case studies, or Svelte out there in production.
Theory is fantastic, right? But we need to ground this in reality to see how it actually performs in the wild. Look at the application of this technology under immense public pressure. The New York Times used Svelte to build their interactive election maps. When you're dealing with millions of anxious people constantly hitting refresh to check live election results, you need absolute, unparalleled speed.
Now, what's really interesting about this is how the Times validated Svelte's capabilities, specifically citing its ability to deliver smooth, real-time updates. It handled high-stakes, real-time data flawlessly, all thanks to those lightweight, pre-compiled bundles.
And they definitely aren't the only ones. Spotify is also leveraging Svelte's simplicity and speed, specifically for their internal tools. So we're seeing massive, highly recognizable engineering teams actively adopting this tech. It's a proven commodity for teams that place a premium on speed, simplicity, and a seamless user experience.
Let's wrap up with Section 5, Challenges and Considerations, and take a grounded look at evaluating the trade-offs.
Because let's be real, in software engineering, there's no such thing as a silver bullet. Every architectural choice has a cost. So let's objectively map out the pros against the cons for some pragmatic decision-making. On the pros side, we've got everything we've discussed today: faster load times, smaller bundle sizes, native state management, and drastically less client-side JavaScript. But assessing the cons, the Svelte ecosystem is relatively young when you compare it to giants like React or Angular. And practically speaking, that means fewer third-party libraries and fewer community resources available to you right out of the box. There's also a unique syntax learning curve for your developers, and you might face potential integration issues if you're trying to drop Svelte into a massive pre-existing legacy codebase. These are very real risks of adopting a younger ecosystem, and engineering managers absolutely must weigh them carefully.
Which leaves us with the ultimate question: is your team ready to trade the runtime safety net for compile time speed? Svelte offers an incredibly compelling, highly efficient architectural shift for modern web apps. The performance gains, they are undeniable. But the decision ultimately comes down to your specific project needs and your team's willingness to adapt to a whole new paradigm. I hope this structured look at Svelte's compile time performance has given you the precise insights you need to make that call. Thank you so much for tuning into this explainer, and keep building.